All right, if you're looking to make sure you don't have mold in your attic, you're also looking to get the longest lifespan possible out of your roof, you really need to consider the proper ventilation for your attic space. And today we're going to be looking at a vented attic, and we're going to be showing you some considerations on what you want to consider when you're designing your home and building your home. We're going to go over attic ventilation calculations and looking at the heel height of your trusses and a few other things that I want to show you. So let's get going. All right, so why do we want to ventilate our attic? Let's start with that. The first thing is you don't want moisture to build up in your attic space that would end up causing mold. So we want it to dry out. So how do we do that? What we're going to end up doing is we're going to actually put vents down low in our, on our roof and then also near the ridge. So through the stack effect, whenever you have heat rising, it's moving that air going through your attic and it's just whisking away all the moisture out the top of your roof. So that's the really important reason for getting the proper ventilation. Now there's ratios that we're going to look at for the attic ventilation ratios on how to actually calculate the space that you need in order to get that proper ventilation. Now also, if you don't have any ventilation inside your attic, it's just constantly just baking, the heat is hitting the outside of your house, it's just baking your composition shingles out there, and there's no flow, no air moving behind it, it's going to really shorten the lifespan of your roof. So we want to make sure we get the proper ventilation in our attic. So when you're calculating your attic ventilation needs, what you have to do is you have to take the square footage of your attic space. So this house here, let's say it's 1,008 square feet. It's just a box. This house is 36 by 28. I would take that 1,008 square feet, I would divide that out by 150, or I'd divide it by 300, whatever the requirement was for the area that I'm in. Then from there, what I would establish, I'd say how many times does 300 go into 1,000? So if it goes in 3.33, then that's going to give me, I need 3.33 square feet of net free air ventilation. So once I know that, I'm going to convert that to square inches. So I'll go to like 100, so I'll go 3.33 square feet times 144 square inches. So I got 144 square inches in a foot. So I now know my total number of net free inches of ventilation that I need. Then I go back and I look at, say, my soffit vents on the outside. And then I'll take and I'll say, well, I can fit a 4x6 hole in this area, which we have behind here. That's, we cut a 4x6 hole, put 1/8-inch mesh on top of that. And then we screwed it in with these lath screws here, 3/4 lath screws. So now I know that I can get, say, let's just call it 48 square inches out of each hole in the house that I have in my soffit vents. And then I'll go through and look at how, then I'll take that 48 and I'm going to divide that into my net square inches. So say it's, say it's 700. I'm going to divide that out by the net square inches that I need. And that tells me how many holes I need to get in here. So I'm going to then lay out the holes that I need inside of my house for my lower vents. So in the lower vents are going to be anywhere from, you don't want any more than 50 to 60% of the total overall net free ventilation. So I'm going to take that number that I need, my total net free inches, and take 50 to 60% of that, and I'm going to put that down low all the way around my house. Then what I'll do is then I want to make sure that I don't exceed, I want to go 40 to 50% of my net free ventilation on my ridge, or up on my gable vents. So I'm going to make sure my gable vent sizes, the net free ventilation, and my gable vents, combination for that, a ridge vent or any other upper vents, don't exceed 40 to 50% of the ventilation that I need. I want to go ahead and I want to get that to draft up and draft out of the house. So that's how I'm going to do those calculations. So you got to make sure you really look at that and lay it out properly. So on this one, these trusses here, these have a 16-inch heel height on them. So we built these walls in between for shear, and also just it's a nice, tall, easier, stronger way to do this. But what you'll see is 16 inches from here to here on the heel height, and that allows you to get a good piece of insulation in here that's nice and deep. So the way the insulation will go in, your insulation will go here, and you're going to have a minimum of R38, maybe R49, and this gives you more space for this heel to just build up this insulation here. So I can get this insulation up nice and high and thick, so I don't get down to where I have nothing right here. A lot of times you'll see trusses that don't have anything right here. They're just where this 3.5-inch top cord touches the edge. You eliminate that by getting a nice thick heel here, high heel, and I can build up this insulation, get it nice and high. So, and then you can even insulate this outside wall, in this scenario, like push insulation into this cavity right here to get it up so you have complete insulation coverage over the top of your wall. So this area here, this is where we've done our attic ventilation. So you can see here we actually have baffles here. This is what we made these baffles. A lot of times insulators will do this. But we bought there's a Simpson LS30. We have a really steep roof in here. And we wanted to make sure we could gain as much possible heel height that we could get. And I wanted more ventilation than just putting like a 2-inch spot up here where the air could flow through. So I wanted to keep as much open airflow to eliminate any mold possibility at all. So in here, if you come look inside of this, you can actually see that we've cut, we ended up cutting 4x6 holes. And this was based off, we had 40 holes that we had to cut in this house that are 4x6 in order to get the proper amount of net-free ventilation. So the way I would look at that is I would say, hey, I got 4x6 be 48 inches, square inch net inches. We'd end up dividing that by, multiply that 6 square feet times 144 square inches. Then I'd divide that by 48, and it would tell me how many holes I have to have. And those may not be the right numbers, but ultimately what you're doing is you're converting your square footage you need in net-free feet into net-free inches in your ventilation, and you divide it out by the holes that you have for your ventilation. So this has an enclosed soffit on the outside. So what we did was we cut these holes, which you can see behind here, cut a hole like this. We ended up putting 1/8-inch wire mesh on here to keep any bugs or anything else that might breach our outside soffits, which should not happen because we have bug screen on them. But this is just a secondary barrier. We got some 3/4-inch lath screws that you can kind of see on the bottom here that we put in here. And then once we got those on, we cut these here. We ran a 2x4 across the top. This is just zip sheeting that we have right here. We turn the zip side on the green side on the outside. And then we put these LS30s on here that allow us to have this angle, this pitch, and hold this real nice, and screwed that in. So this allows this insulation now. What happens is it goes here. This is the bottom, and then we just cut it a little shorter and build it up. We can get this up as high as we go. I think this is going to end up being like 14, 15 inches deep. So it gets a little thinner as we go up here because of the way this was built, but this is the best we could do with this, and we still get a nice high heel height over here. This is at least another, we're getting at least here another, we got our wood plus this, that's 6 inches here minimum versus what we'd have down to nothing if we didn't have this here. And then over here we're getting a full 16 inches of heel height on this with their insulation. So it's going to give us a better energy component to the house by doing that. And then the other thing it makes sure of is if you're like in a high wind area, if they don't put those baffles in good, like they staple these fiberglass or kind of like styrofoam baffles up in here, they come down, they leave you a 2-inch air gap, and they'll come down like this. They can blow out and come loose in areas like this area where this house is at, get sometimes 60, 70 mile an hour winds. And it just comes blowing through these vents, and it'll blow those out of the way. And the other thing, if you have blown in insulation, would not recommend having any blown insulation in high wind areas because it just blows it out of the way. You end up with these flat spots up in here unless you baffle it really well. So this house is at getting batted insulation specifically for that reason, and also just because it's easier if you're doing any modifications, it's not as messy. These are the lower vents, so you would calculate out that the lower vents to have anywhere from 50 to 60% of the required net-free ventilation, and then what we do is we make sure this is going to flow up. So in this instance here, you have a scissor truss here that's running up, and then we have these gable vents that are all the way up at the top. There's one on each end of this house. So this house is only about 36 feet wide. So that travels up and out those gable vents. We did not want to put any ridge vents in this house or any O'Hagan vents at the ridge because just for penetration of water and maintenance over time. It's a 12-12 pitch on this roof. We did not want to have any chance we had to get up on that roof to maintain anything or fix anything or caulk anything. So we did everything on the sides with these gable vents, and I'll show you over here. This one has, if you look up here at the top, we actually built a kind of a, let's call it a catch basin or kind of a pan up top there for our gable vent. So what it is the gable vent comes in. We'll have some B-roll to show you this, but the gable vent is on the outside of the wall, and then we've built this pan that has an angle at it, so it's actually made out of zip. It goes all the way out. The gable vent has a small gap at the bottom, like 1/8 of an inch or so, and then we've made a pan that is actually falling back out, so any water that comes in, it sheets out of the house. So if you get any driving rain, it's not coming in your attic. So big issue with, like, we didn't want to have any issues with mold in this house or moisture or anything. So lots of decisions were made to avoid that, to avoid those issues. So that was one of the things that we thought through and wanted to add. So this center section of the house right here, you can see there's baffles up here as well. There's a dormer outside, and this we got about 3 feet right here. So we've got vents in every one of these coming through in the soffit. Then that goes up through these trusses, and we made sure these are actually parallel trusses. So they're 12-12 pitch on the top and the bottom. This one, so that the insulation here, we selected an insulation that's short enough on the height that will, and design these trusses to where we have an air gap below the bottom of the top cord. And then the air comes in here, it goes underneath the bottom cord, so it's got maybe this much space underneath the bottom of the top cord. It flows over, goes up through a fill in the roof and out the gable vents. So we've avoided any roof vents on this roof by designing it that way. So you got to make sure your parallel trusses are tall enough to accommodate the required amount of insulation that you have on your ceiling. So it's R39 or R38 or R49 or 60, whatever it is. Make sure that you could adjust the parallel truss depth in order to accomplish that cross ventilation that runs from the low point to the high point to get you to your high point. All right, so we're up top here in this roof, and I wanted to show you guys how we actually vent this. So the cross ventilation in these parallel trusses, you can see that the air actually moves through these webs. So the insulation is up into here, and the air moves through the webs. And then if you look up here, you're going to see some holes that have been cut in this fill. So that's the actual outside, the high part of the roof outside. So this calcs out to where it needs about 2 square feet of ventilation for the center section of roof that then goes out to the gable vents. And so we've cut, on each side, we've cut a 12 by 12 hole here for that air to come up and then go out the outside of the roof. So now what I'll do is I'm going to go ahead and take you over, and we're going to look at the gable vents on the end so you can see what those look like. You can see the pan that we built to keep the water and sheet the water outside. So I'm up here in the attic now. I want to show you something before I get over to the gable vent that we built here, and you can see this ventilation hole. So this is the fill that we did in the roof that you can see from the other side where we put the vents come into this higher part. So this is the attic access in front of me here, and then this over here is that 12 by 12 hole in the fill. So you can see this is the top here where we built over the top here for the higher part of the roof. And so this is where the air is coming across from this section of roof that's behind this, and then it comes over and then vents up the top, and then we don't have any ridge vents up here, and then it's traveling over where we're getting ready to go and out that gable vent on the other side. So it's actually up higher. So you get up high, you can see the vent that way. So I'm too low where I was looking at right there, but you can see through this, and the air travels through this upper part of the roof. So we're gonna go over there now, and I'll show you how that gable vent is constructed. So we got this catwalk here that we built that you can walk all the way out to the end of the gable on each side. There's a radon fan in front of us here. And I built this pathway up here to our vent. So you can see here how we built this pan. This is underneath, this is out of zip. So the zip's on the other side of this, but this is essentially a pan that you can see, so you can get up in here. There's the gable vent, and it's louvered, and then you have this pan that's built here that you can see, and we got zip, stretch tape or just regular zip tape on this, and it kicks out everything to the outside. If anything drives in, there's no way that water's coming into this attic through this gable vent with this design here. All right, well, that was an example of a vented attic system. There's other options out there, but if you have the opportunity to vent an attic, it's always the best move to avoid any mold or moisture issues that you could potentially have. So if you'd like to build for a healthy home, I always recommend a vented attic if possible. So if you'd like information about building a custom home, building an ADU, or doing a whole house remodeling project, reach out to us at freemansconstruction.com. If you're needing help with your real estate needs, you can go to our real estate company's website at freemansrealty.com. Thanks again for watching.